Hello, everyone. My name is Konstantin Klemmer, and I'm a PhD student in computer science at the University of Warwick in the UK, as well as a visiting student at NYU. Today, I'm presenting our paper, Auxiliary Task Learning for Geographic Data with Autoregressive Embeddings. This is joint work with Professor Daniel Neal at NYU. In a nutshell, our paper proposes a new multi-resolution expansion of the local Moran's I metric of spatial autocorrelation. We then use this metric and integrate it into neural network models via auxiliary task learning. We show competitive results on generative and predictive spatial modeling tasks. First, we propose a novel multi-resolution version of the local Moran's I metric. This is facilitated by repeatedly downsampling the input data, analogous to an average pooling operation in most neural network libraries. We then compute the local Moran's I of the coarsened input. Lastly, we upsample the coarsened Moran's I back to the original input size during nearest neighbor interpolation. Our new multi-resolution Moran's I captures spatial interactions over short and longer distances and tackles the known scale sensitivity of the metric. Second, we use the Moran's I metric as an auxiliary task. Auxiliary task learning describes the special case of a multitask learning approach where we are only interested in the outcome of the main task, but provide auxiliary tasks to improve the capacity of the learner and to nudge it into the right direction. This approach is popular in the computer vision community especially. It also requires that the auxiliary task is meaningfully related to the main task. We find that the Moran's I and the multi-resolution expansion can be successfully used as an auxiliary task for geospatial data and consistently improves performance of neural network models. The loss of the auxiliary task can be controlled using a weight parameter, here in this example, lambda. But another option is to use the weights of the auxiliary tasks to learn the weightings on the flight. Here, we use an approach proposed by Kendall et al. In their 2018 CVPR paper. We use the task-specific uncertainty to balance the losses of the different tasks. This way, we can avoid having to set hyperparameters for the auxiliary task loss weights. In our first experiments, we propose the first GAN using uncertainty task weights for managing auxiliary tasks. We test our GAN for generative modeling on a range of different spatial data sets. For example, here we learn to generate geospatial tree canopy patterns using Moran's I auxiliary tasks at 3 different resolutions to improve the learning. Our generated data visibly improves over benchmark models. In our second experiment, we tackle spatial interpolation or image super-resolution. We again find that augmenting a learner, here CNN, with our auxiliary task improves performance. Again, our approach improves over a set of baseline approaches. Thank you for attending our presentation, and please reach out if you have any questions on our work.